Everything? Alright, ladies, so let's go over this question, okay? So we're going to go over number 5. So, look, probability question they're tricky, to be honest with you.
I literally did this. I couldn't even do the basics.
Okay. So the question that you're going to get on your quiz tomorrow is going to be much easier than this one. Okay. But your unit test, don't be surprised if you get a question like this, okay? So if you can solve this, the question you're going to get on a quiz tomorrow will be kind of like a scaled down version of this. So I'll show you what I mean by that, okay? So let's look at this question. So we talked about this a little bit yesterday, so I'm going to review. So we got Tom, and we have Sally, right? So the question says, Tom's father had Huntington's. So if we look at family tree, so Tom's father had it. So we know his father had one big H. But Tom's mom was normal, which means Tom's mom was little h, right? Now, it says, his paternal grandfather was normal. So, Tom's father had Huntington's, and Tom's father's, hold on, let me slide over. So if we look at, so this is Tom's father right here, okay? It says Tom's paternal grandfather, which is his father's father. I ran out of room here. So, was normal. So that means that Tom's father has to be heterozygous. Okay, because Tom's father's father was normal. Now, Sally's situation, Sally's mother had Huntington's. So we know she has, it actually says that her mother had Huntington's. So if we do the mother on this side, we know the mother has at least one big H. Sally's father is normal. So we know Sally's father is little h. And it said her maternal grandfather was normal. So that means Sally's mother's dad was little h. So therefore, Sally's mother must be heterozygous. This is where we left off yesterday, okay? Now, if Tom and Sally get together to have a child, what are the odds that that child has at least one little h? One big H. Because remember, Huntington's is dominant, right? We're going to assume it does not affect your ability to have kids because you don't really see it until after you have kids. So let's think about the scenarios for a child to get Huntington's.
Please excuse this interruption. This announcement is for any student who has not attended.
All right, so let's look at this.
Bye. Bye, you too.
Bye. Let's look at Tom. Okay? Tom. What are the odds that Tom is affected? Well, according to this, we know that Tom is going to get a little h from one parent, and the other parent is 50-50 whether he gets the big H, right? So that means Tom has a 1/2 chance of being affected, A, and a 1/2 chance of being unaffected, U. Correct? Sally is exactly the same. So Sally is 1/2 chance of being affected, because look, for sure she's going to get a little h, but there's a 50% chance she gets a big H. Because 1 out of 2 is big H from this side of the family. So again, Sally's the same. Now, for a child to get affected, we talked about 3 scenarios yesterday. Scenario 1 is Tom is affected, Sally is unaffected, and then we talked about the children being affected, right? And we talked about the outcomes for that. So let's just keep it simple. Let's just talk about the probability of Tom being affected and Sally being unaffected. That's one scenario. The other scenario is Tom is normal, unaffected. Sally is affected. And then we'll talk about the children separately. And then the third scenario is what? Tom is affected and Sally is affected. Okay? And then we'll talk about the children separately. Okay, so let's look at this. Let's change the color actually, so it's a different color. Tom being affected, 1/2, times Sally being unaffected is 1/2. So this sequence is 1/4. Okay? Tom being unaffected is 1/2. Sally being affected is 1/2. So that's also 1/4. And then the third scenario is both Tom and Sally are affected. So again, that's 1/2 times 1/2, which is 1/4, okay? Now, so let's go back to sequence 1. So all we've done right now is we figured out what are the odds that Tom is affected and Sally is not, or Tom is normal, Sally is, or both Tom and Sally are affected, right? So let's look at sequence 1. Sequence 1, Tom is affected, Sally is unaffected. We said is a 1/4 chance of happening, right? Whoa, what happened there? Sorry. Erase that. Fix that a little bit. Okay. Now, let's look at the children. Because the question says you have 3 kids. So 3 kids right here. And 2 of them are affected. If Tom has it, Tom would be big H, little h. And if Sally doesn't have it, she would be what? Little h, little h. Now, if you did a Punnett square, you don't need to do a Punnett square, but if you did, so Sally would be little h, and Tom would be this. So you could see that it's what? What chance of being affected? Yeah, 50. 2 out of 4, right? So let's think about the sequences now for the kids. Okay? What are the possibilities? Well, we talked about child 1 could be affected, child 2 could be affected, child 3 could be normal, or what? What is it? What's another possibility? Child 1 is unaffected, the other 2 are affected, or affected, unaffected, affected. Okay, so what we're going to do is this. We know there's a 1/4 chance that Tom is affected and Sally's not. But now we're going to figure out what are the odds of these 3. We're going to use the sum rule, right? We're going to first use the product rule, and then we're going to add up. So let's look at this sequence here, AAU. So what's AAU? So A is 1/2. A is 1/2. U is 1/2. Whoa. Fix this. Okay. So this sequence here, AAU, is 1/2 times 1/2 times 1/2, right? But we have another possibility. Remember, the sum rule is you look at the product rule for each sequence and you add it up, right? So what's the other possibility? It could be UAA. So a question that you would get on the quiz tomorrow would just be something like this part. Would just be like, imagine Tom is heterozygous and Sally is normal and they have 3 kids. What are the odds of 2 are affected? So you would just be doing this little part. You wouldn't be doing the whole thing because that becomes obviously more complicated. All right? So what's the sequence of UAA? Well, it should be the same, right? It should be 1/2 times 1/2 times 1/2. So 1/2 times 1/2 times 1/2. Now, Really? Do you need to do all this? What's a half times a half times a half? This is 1/8. It's 1/8. This is 1/8. So guess what the next one's going to be? Yeah. So it's going to be a half times a half times a half. But we know it's going to be 1/8. So for the first scenario where Tom is affected and Sally is not, the final answer for that section would be 1/4 times the sum of 1/8 plus 1/8 plus 1/8, which is 3/8. So that would give you 3 out of 32. Okay. Now that is just for what? That's for Tom being affected. That's this one, right? Tom is affected. Sally is unaffected. We just figured out it's 3 in 32 chance of that happening. Which of those other two would be the mirror image of number 1, which would give you the exact same result? Yeah, this one. These two are mirror images of each other. So for 2, we could say it's the same thing. Let me just give me a little bit more room here. So we could say that 2, sequence 2 where Tom is unaffected, but Sally is affected, and we have, again, 2 out of 3 kids are affected, it has to be the same. It has to be 3 out of 32. Right? Exactly the same as sequence 1. The one that is different is sequence 3. In sequence 3, we have Tom is what? Tom is affected, and Sally is affected. Now, let's think about that. Tom is heterozygous. Sally is heterozygous. If we do the Punnett square, what do you get? So here. So this one is homozygous dominant. This one's hetero. Hetero. Only 1 in 4 is 1 in 4 is what? Unaffected. 3 in 4 is affected. So you can see the probability is not the same as the other one, and the other one was a half and a half, right? So here's the thing. We just looked at what's the odds of Tom and Sally both being affected, right? And we said it was what? 1 in 4. So now we have to look at the sequence again. Okay. Child 1 is affected, 2 is affected, 3 is unaffected. Child 1 is affected, 2 is unaffected, 3 is affected. And what's the third possibility? Unaffected, affected, affected, right? And we just work out each one again. But it's a little bit different. But here's the thing. The odds for each of these 3 should be what? The same. Look. What's this going to be? This is going to be 3/4 times 3/4 times 1/4, right? Based on what we just talked about over here. Whatever you get over here, it has to be the same for this one and this one, because it's still 2 A's and a U. So you don't need to work all 3 out. You just need to work one of them out. So let's just work one of them out. So what's 3/4 times 3/4 times 1/4? Well, that should be 9 over 64. So this is 9 over 64. This also has to be 9 out of 64. And this has to be 9 out of 64. So that means we're left with this. 1/4 times the sum of these 3. Which has to be 27 out of 64. Yeah, sorry? Yeah, because 4 times 4 times 4 is 64, right? 64, yeah. So the odds of this sequence, Tom affected, Sally affected, times 2 out of the 3 kids being affected, would be 1/4 times 27 over 64, which gives you 27 out of 256, I believe. Okay? So now, are we done though? No, because now what do? Is we say, well, we have 3 scenarios. There is no 4th. The 4th scenario is Tom and Sally are unaffected. But if Tom and Sally are unaffected, can the kids get it? No. Okay. So what's the final answer then? What do you think the final answer is? Well, we have to add up sequence 1, which we figured out was what? 3 out of 32, with sequence 2, which is 3 out of 32, with sequence 3, which is 27 out of 56. So our final answer, like Jeopardy, final answer would be 3 out of 32 plus 3 out of 32 plus 27 out of 256. This, if you do common denominators, I believe this is this 24 out of 256 is equivalent to 3 out of 32. As you know, you learned in math you can't add things unless they have the same denominator, right? So, now truthfully, you could leave it as a percent if you want. You could just divide 3 of 32 as a percent and add them. You don't have to leave them as fractions, okay? So this will give you 48. This is 48 plus 27 is 75 out of 256. That's a huge question. That's not what you're getting on tomorrow's quiz. Okay? Tomorrow's quiz, you'll get a small version. You get, this is what Tom is, this is what Sally is. Because in this one here, you have to think about what Tom and Sally might be. Tomorrow I'll tell you, no, Tom is this, Sally is this. They have 4 kids. Work it out. Yes. Yes. Okay, so let's look at this one. This one will be a lot easier to work out because you don't have to consider different scenarios here. There's only one scenario. It says Jack has Huntington's. Assume he's heterozygous. We have to assume that she doesn't have it. Because otherwise you can't solve the question. In the previous example I showed you, you could work out the probability of Sally and Tom. If I don't tell you anything, you can't work out anything. So, in this question, you have to assume that, yes.
Well, when she are you going to tell us she has big H, little h, or big H, big H?
No, then she would have it.
Well, like, but it doesn't, like, specify.
Right, so then you assume she doesn't have it.
So you just assume.
Yeah, yeah. In the previous example, I gave you information about Sally and Tom's parents and stuff like that, and you could work out that they were heterozygous, right? Here, you're not told anything, so you got to assume that she doesn't have it.
So if you don't have any information,
then you assume she doesn't have it. Yeah. That's weird. Well, not really, because you got to consider the odds of someone having Huntington's is very, very small, right? It's very small. It's not like a type of allele that a lot of people have it. It's very, very rare. So it's pretty safe bet that they don't have it. Okay? So, if that's where you had problems with, then don't worry. If a question like this, I would say, well, you got to just assume that they don't have it. Okay. So we kind of already worked this one out. If he has 3 children, what are the odds that one child? It's like a mirror image of the other one we just did, right? So look, if we look at Jack being heterozygous and the wife is normal, what are the odds that the kid has it? Well, so a question, I'll give you an example. Tomorrow you're going to get a question with a Punnett square. So your Punnett square question could be this one. Jack has Huntington's. Wife is normal. What are the odds one kid has it? So then you would say, well, Jack is big H, little h, so we do this. And here's your Punnett square question. that you might see tomorrow. Right? Because really it's the same thing. But as soon as I start asking about questions where you have 3 kids, what are the odds that 2 of them have it, then you gotta start using the sum rule. You can't just use the Punnett square, right? So, here's your Punnett square. You're gonna get a question like that. So according to this Punnett square, half chance of being affected, half chance of being what? Unaffected. Now, we need to know that because now the second part of it is you have 3 kids. What are the odds that 1 child has it? Okay? Now be very careful with the way the question is worded. I have a feeling tomorrow the biggest problem for you guys is the wording of the question. I'll show you what I mean by that after. Okay? Let's just solve this question first. 1 child has it. What are the possibilities? Okay? 3 kids. So it could be A, U, U. It could be U, A, U, or U, A, A. Sorry, U, U, A. Now, each of these 3 is going to be the exact same probability, right? So, we just have to work out one of them. So, what's the odds of being affected? What's the odds of being unaffected? And the odds of being unaffected? So, this sequence is 1 in 8. This sequence must also be 1 in 8, and this sequence must also be 1 in 8. It is, yeah. So then the answer for this is 3 out of 8 because you do the sum rule now. So again, a Punnett square question could just simply be the first part. Work out the probability of 1 kid of getting it, right? Using a Punnett square. Then it becomes more complicated if I say to you, you have 3 kids, what are the odds of 1 having? Now, I can make this question more complicated.
Wait, sir, 3 over 8 there's a very chance that 1 child has it.
Well, I could say, what are the odds that at least 1 child has it? Now, at least. So then let's think about that for a second. Let's imagine I change this. Instead of saying 1 child, let's say at least 1. It's not. I want you to think about this, okay? At least 1 means what, Sabrina? 1, 2, or 3. So I can do this. I can make my life very difficult and work out the odds that 1 child out of 3 will get it, which we just did. This is that one right over here, 3 of 8. Or we could do, what are the odds that 2 out of 3 will be affected? In that case, that would be, well, okay, then we do A, U, A, U, A, U, A, A. And in this case, it will be a half times a half. Again, you'll notice they're all going to be 1/8, right? So that will give us 3 out of 8. Yep. And then we have this possibility where all 3 get it, and there's only one possible way that's going to happen. That would be what? A, which is what? It'll be 1/8, right? 1/2 times 1/2 times 1/2, and that gives us 1/8. And then we say, so now the question is, what are the odds of at least 1 getting it? Well, 3 out of 8, 3 out of 8, 1 out of 8. The answer is 7 out of 8. We could do it that way. We could have done it differently though. Instead of asking, think about a way we could ask the question so that's different, but it gives you this pretty much same answer. Instead of saying at least 1 kid, we could say, what are the odds that none of them have it? Think about that for a second. If we ask the question, what are the odds that none of them have it? That would be the mirror image, right? That would be the opposite of the question, at least 1. So then, what are the odds of this sequence? Unaffected, unaffected, unaffected. That has to be 1/2 times 1/2 times 1/2, which is 1 out of 8. That means you're left with 7 out of 8. What's the other 7 out of 8? that must be at least one being affected. So sometimes you might come across a question where if you change the way it's worded, maybe you can think of it from taking it or tackling it or solving it from a different point of view. Okay? You can possibly do that too. Alright? Yeah. Yeah, I'm recording. That's okay, Petra. I have you on record in there. Yeah. Just the right way.
Oh my God.
I'll just pause.